This conference will now be recorded.
Okay. So today we are going to learn. We are going to learn um, what is containers. Or let's say what are containers? Okay, so containers. And before that, we are going to discuss a few questions like first of all, what is physical server? Okay, and what is virtual machine? And what is container? Okay, and the difference between the physical server and the VM virtual machine and the container. Container. So here we will discuss about what is Docker. Okay, containers, and after that we'll discuss about Docker architecture. Okay. Now, so coming to the first topic. So first thing is physical server. Okay, so the first topic is physical server. Generally, if we want to install or if you want to deploy any application, what is it? What is it required in our organization? So if we need to deploy one application on a server, first the first thing is we need physical server. Okay, we need physical server. Okay, so on the physical server, let's say this process like how to execute normal applications. Okay. So in this process, okay, execute or deploy normal applications. So the requirements, if you want to deploy or execute any normal application, the first requirement is we need physical server. Okay, physical server is nothing but it could be a computer. Okay, with a Windows operating system or server. Generally we use EC2 server, right? So it could be that server. Okay, or virtual machine. What is virtual machine? I will tell you. Right. Okay. So generally we need a physical server. So our organization, it will provide one laptop. Okay, and under this, what we will do? We will install one operating system, the physical server. We will install one operating system. Let's say, for example, something like Windows, could be any version. We will install operating system and to install some dependencies. Okay, we'll install some required softwares and dependencies. Okay, so generally dependencies like Java. Suppose if you want to deploy Java, web application, so you need Java, right, software. So we install this Java version. Okay, so this is process for executing normal application. Let's say we are executing, we are trying to um, yeah, we are trying to build one Java web application. Okay, so Java web application, and for that our organization has provided this 24 GB RAM. Okay, 24 GB RAM and 1 TB hard disk. Okay, 1 TB hard disk and one processor. Okay, I mean processor is nothing, CPU it is nothing but, let's say for example it is quad core. Okay, quad core CPU. So for deploying one web application, one Java web application, either it may not be one or for deploying one or two Java applications, your infrastructure, what do you say, your organization has provided um, a laptop with 24 GB RAM and 1 TB hard disk and quad core processor. Okay, now on top of this, okay, either you can install, let's say for example, um, Windows. Okay, let's say they give, they provided one plain laptop. You can install Ubuntu, install Windows for deploying your Java web application. Okay, and in case if you don't want Windows, you can install Ubuntu directly on this physical machine, and you can deploy the required application, whatever you want to deploy. Okay, so these are all operating systems. Okay, Windows and Ubuntu, we know that. So for example, if you deploy two Java applications, if you deploy two Java applications, okay, let's say for example each Java application took 2 GB of RAM. Okay, 2 GB of RAM. So total 2 into 2 GB, how much GB is consumed? 4 GB is consumed. Okay, generally hard disk also, for deploying one application, it won't take 1 TB. It will take in MBs, not in TBs. It will be very minimal use. Okay, for Java, for deploying two Java applications. Here, out of 24 GB, only 4 GB is used for deploying my application. Okay, only 4 GB RAM is used for deploying my application. So if you compare, out of 24 GB, 4 GB used, what about the remaining 20 GB? So we cannot do anything with that remaining 20 GB because we have to deploy. If you deploy another applications, let's say for example, if you deploy another applications with another dependencies, let's say in the same Java, in the same machine, if you deploy some .NET with different packages, so the dependencies may collide. Okay, and the internal softwares may collide, and our web application may not work. Okay, and this web application may not work because we are deploying these machines. Okay, we are deploying these applications on only one machine. They are using same resources. Okay, 24 GB RAM, 1 TB and quad core. If you deploy same .NET, okay, same .NET application in the same machine with this 24 GB RAM, okay, after 4 GB is used, if you deploy same application, internally what happens is these softwares, the dependencies which are required to install this .NET application may collide with Java. Okay, and you may get some other exceptions. So there should be isolation between these applications. Okay, there should be isolation between these applications. So for that purpose, okay, they came up with concept called virtualization, server virtualization. And before going to server virtualization, why server virtualization came into picture? Because if 4 GB is consumed for deploying one application, let's say for example, out of 4 GB, 20 GB RAM is free space. Okay, and your organization is spending money for 24 GB. So this is sheer waste of money. Okay, this is nothing but sheer waste of money and resources. So if you can accommodate this server for multiple applications, multiple deployments, okay, and that will be a good option. So for that purpose, they have come up with virtualization concept. Okay, virtualization concept. So in the virtualization, what happens is we'll be having same things. Okay, we'll be having same things. They will provide this. Okay, they will provide this. Okay, and also we're going to install. They will install operating system as well. Okay, they will install an operating system as well. On top of this operating system, okay, there is a software called hypervisor. Okay, there is a software called hypervisor. Okay, so hypervisor is nothing but hypervisor, also known as virtual machine monitor, is software that creates runs virtual machines. Basically, what are these virtual machines? I told you, right? So, for if you deploy, if you use these instances, like these resources, you can deploy only few applications. They are of same type. Like if you want to deploy two Java applications of same type, you can deploy. But if you want to deploy one .NET application and one Java application in the same server, it will they will collide and there won't be any isolation between these applications. But in case of virtual machines, what happens is on one operating system, if you install this hypervisor software, okay, if you install this hypervisor software, you can create uh, multiple virtual machines. Okay, multiple virtual machines. I'll show you how this will be. See, if you see this image, okay, these are nothing but hardware resources like RAM, CPU, memory. Okay, this is a host operating system. Like consider it as Windows. Okay, so if you install hypervisor software on it, okay, if you install hypervisor software on it, on top of that you can install one Ubuntu operating system, and you can create one virtual machine. Okay, and on top of this you can install one Ubuntu, one CentOS, okay, one CentOS, and on top of that you can install your required application. Okay, here we are providing different isolated environments for our applications. Okay, here we are providing different isolated environments for applications. Okay, if you see this, I want to deploy, let's say for example, 3 applications. Okay, where on top of my infrastructure, on type 1, you can directly use the hypervisor software and create multiple, install multiple operating system on one server. You can install Ubuntu, and on one hub, one section you can install CentOS, and one section you can install Windows. On top of the operating system, you can deploy your respective application. Okay, let's say for example, if Java application requires Ubuntu, you will install Ubuntu here, and then you will deploy Java application here. And if what is it? If .NET requires CentOS, okay, just for example, I'm explaining. If .NET requires CentOS, you can install CentOS and you can deploy your .NET application here. Okay, like that. If you install hypervisor software, okay, if you install hypervisor software, you can create number of virtual machines. These are nothing but virtual machines. So each and every virtual machine act as a server. Okay, it is nothing but act as a server. Generally, for server, what we need? We need operating system. So here we have operating system. Okay, we need hardware resources, right? So this virtual machine, it will share the hardware resources of that physical machine. Okay, let's say for example, this is my Windows machine. Right now I am explaining my class on my Windows operating system, right? On top of that, if I install virtual machine, okay, sorry, if I install hypervisor software, I can install Ubuntu. Okay, I can install on Ubuntu, and I can deploy my applications on top of that Ubuntu. Okay, సో ఇక్కడ ఏం జరుగుతుందంటే ఈ హైపర్వైజర్ ఇన్స్టాల్ చేసుకుంటే మీకు నెంబర్ ఆఫ్ వర్చువల్ మిషన్స్ క్రియేట్ చేసుకోవచ్చు. ఈచ్ వర్చువల్ మిషన్ ఒక సర్వర్ లాగా యాక్ట్ చేస్తుంది. ఈ వర్చువల్ మిషన్ ఏం చేస్తుందంటే అండర్లైన్ ఆపరేటింగ్ సిస్టమ్ రిసోర్సెస్ ఉంటాయి. అండర్లైన్ ఆపరేటింగ్ సిస్టమ్ రిసోర్సెస్ అంటే నథింగ్ బట్ మన ల్యాప్టాప్ రిసోర్సెస్. ఓకే, ఆ 24 GB ర్యామ్ అండ్ క్వాడ్ కోర్ ప్రాసెసర్ CPU, ఓకే, అండ్ 1 TB హార్డ్ డిస్క్, ఆ రిసోర్సెస్ యూజ్ చేసుకొని ఆన్ టాప్ ఆఫ్ దట్ అదే రిసోర్సెస్ షేర్ చేసుకొని మనం మల్టిపుల్ వర్చువల్ మిషన్స్ క్రియేట్ చేసుకోవచ్చు. లెట్స్ సే ఫర్ ఎగ్జాంపుల్ యూ కెన్ క్రియేట్, suppose each virtual machine requires 4 GB. Let's say out of 24, how many we can create? 4 4 16, 8 we can create 8, right? No, 6. Okay, we can create 6. So like that you can create number of what is it, virtual machines on top of the um, single server, okay, single laptop on top of single laptop using these resources like 24 GB hard disk and 24 GB RAM, 1 TB hard disk, and the quad core processor. If you install with hypervisor software, it will share the resources of your physical machine, and then you can create number of virtual machines on top of that. Okay, you can install the guest operating system software and on top of it, and you can deploy your applications. So here we are doing virtual server virtualization. Meaning server virtualization is nothing but we are creating multiple servers on top of a single machine. Okay. So let's take this definition. So hypervisor ఏం చేస్తుంటే hypervisor సాఫ్ట్వేర్ ఒకదే విండోస్ ఆపరేటింగ్ సిస్టమ్ మనం వాడే ల్యాప్టాప్ లోనే విండోస్ ఆపరేటింగ్ సిస్టమ్ పైన హైపర్వైజర్ మీరు ఇన్స్టాల్ చేసుకుంటే హైపర్వైజర్ మీద on top of hypervisor you can install multiple operating systems, and on multiple operating system each are isolated. Okay, each are isolated. So multiple in the sense one or two. Let's say for example in one virtual machine installed for creating one virtual machine it requires Ubuntu install చేసుకొని ఆ virtual machine మీద మీరు Java application deploy చేసుకోవచ్చు. For one virtual machine if you need CentOS, you can install CentOS, and on top of that you can deploy for any application. Even if it is the same application, Java application, like CentOS operating system అలా కూడా deploy చేసుకోవచ్చు. Okay, so best what do you say softwares for this server VMware virtualization is VMware, okay, Oracle Box, okay. Like this we have virtualization softwares, okay, virtualization softwares. So generally people who don't want waste their resources like this 24 GB RAM and 1 TB hard disk, they buy it. If they want to deploy multiple applications on top of that, okay, they will install this Oracle Box or what is it, VMware. On top of that they will install multiple operating systems, and then they deploy their applications. Okay, but here the disadvantage of using this hypervisor software is not the disadvantage I would say, but the problem with using this virtualization or hypervisor software is if you want to in the real time, if you want to work on organizations. So let's say for example you have a requirement to install or deploy to onto Java web applications. For that purpose you need to buy license for operating system, okay, for each and every this thing. Okay, this is my image. If you check this image, okay, if you want to install CentOS, let's say for example let's consider this as a Windows machine. Okay, on Windows machine we install hypervisor software and we are creating multiple machines. Okay, one is CentOS, let's say for example one is Ubuntu and one is Windows. So you can install multiple operating systems. Let's say for example if you install guest operating system, let's say for example Ubuntu. Okay, if you install Ubuntu on top of this operating system, okay, and let's say you install CentOS on this hypervisor and Windows on this hypervisor software. Okay, so you need 3 different operating systems for deploying 3 different applications. Okay, so when you need 3 different operating systems for deploying 3 different applications, you are going to spend money on these licenses. Okay, each and every operating system they require license for deploying their applications. Okay, generally in real-time organizations you don't deploy open source or keyless means temporary operating systems. Definitely you need to use licensed version operating system, okay, for deploying standard applications. So if you deploy without operating system, if you deploy without standard operating system, there will be some bugs, and sometimes the operating system may get expired in couple of days. So for that purpose, we need to use licensed version of operating system. So for that purpose, if you want to buy, if you want to install Ubuntu on one machine, you need to purchase one license, okay, license, and for CentOS you need one license. Okay, like this for each and every
బ్రో
software. uh,
బ్యాక్గ్రౌండ్ ఏదో సౌండ్ వస్తుంది బ్రో.
1 minute. Close my door. ఇప్పుడు ఓకే హరి, స్టిల్ ఇప్పుడు అంతే వస్తుందా?
ఇంకా గట్టిగా వస్తుంది బ్రో.
అంటే అది మేబీ మౌస్ అయి ఉంటది బ్రో, మౌస్ కీప్యాడ్.
కాదు అగో
ఓకే ఇప్పుడు
మళ్ళీ వస్తుంది. అగో
ఓకే ఓకే.
వస్తూనే ఉంది బ్రో.
యాక్చువల్లీ దిస్ ఇస్ మై ల్యాప్టాప్ ఫ్యాన్. ఓకే, సో ఫ్యాన్ రన్ అవుతుంది కదా, హీట్ అయినప్పుడు ఫ్యాన్ సౌండ్ ఎక్కువ బాగా వస్తుందా?
అవునవును.
ఓకే, సో మేబీ ఐ థింక్ నేను షట్ డౌన్ చేసి మళ్ళీ లాగిన్ అయ్యి ఎక్స్ప్లెయిన్ చేయాలి అలా అంటే. ఓకే,
సరే ఇవాళ కంటిన్యూ చేయండి.
నో యాక్చువల్లీ సుష్మిత, ఐ మీన్ ఈ క్లాస్ రికార్డ్ అవుతే ఫర్ ఎగ్జాంపుల్ బ్యాక్గ్రౌండ్ నాయిస్ చాలా ఎక్కువ ఉంటుందా లేకపోతే తక్కువ ఉంటుందా? మీకు ఎలా ఉంటుంది యాజ్ ఏ ఆడియన్స్? సుష్మిత ఆర్ హరి, అంటే బాగా వస్తుందా? బాగా వస్తే తప్పదు రీస్టార్ట్ చేయాలి.
అంటే మీరు మాట్లాడేదని అది సింక్ అవుతుంది, అంటే కొద్దిగా టకాటక్ టకాటక్.
ఓకే, లెట్స్ డు వన్ థింగ్. సుష్మిత, హలో, యూఆర్ ఆన్ మ్యూట్ సుష్మిత. వాల్యూమ్ వాల్యూమ్ ఇంక్రీజ్ చేయండి సుష్మిత, మీ ఆడియో. Hari, I think it will take 5 minutes for me to log in. So I'll restart my laptop and I'll log in again.
ఓకే బ్రో.
This conference will now be
సరే అన్న.
recorded.
సరే.
Okay. So, till now, ఇది వినిపిస్తుందా? హైపర్వైజర్ అంటే ఏంటో చెప్పినప్పుడు.
బ్రో వినిపించింది.
Okay. So hypervisor is nothing but if you install hypervisor software on top of your physical machine. Okay. So you can deploy multiple. You can install multiple operating systems, and you can install deploy multiple applications. Okay. You can deploy multiple applications. So for each and every what do you say? For each and every operating system, you need to spend money for license. Okay, you need to spend money for license. Okay, so let's say for example, if you are using Ubuntu, for Ubuntu you need to spend money. For CentOS you need to spend money. Okay, here, so the major focus is going on purchasing the infrastructure Okay, purchasing the operating system licenses rather than deploying applications. But our main motto, okay, our main motto is to deploy application. Okay, not to purchase, not to spend money on the uh, required licenses and all, right? So here we are giving more importance to buying, purchasing licenses and installing operating system rather than focusing on applications. Okay, so to overcome this issue, industry has come up with one technology called Docker. Okay, okay, they have come up with a technology called not technology called Docker. They have come up with a technology called container. Okay, so Docker is one company which is providing containers, but before that, there are multiple companies we have containers, and also in the Linux from the starting day one itself, Linux has separate container system, but nobody has recognized that container system, and nobody is using it. Okay, so the Docker is a software company. They came up with this approach, this container approach. So they want isolated environment for deploying, for developing and shipping and deploying their applications. So they have come up with this idea, container technology idea. So it is very popular among the software industry. Okay, most of the time, if you check any organizations, they'll use Docker only. Okay, so before going to Docker, um, let's see what is a Docker container. Okay, so in case of virtual machines, in case of virtual machines, what we are doing, we are, the organization will provide the same infrastructure, like, the RAM, memory, CPU, okay, and same thing here also, they'll provide RAM, hard disk, and CPU. But in case of virtual machines, what are we doing? We are installing hypervisor software, and on top of the hypervisor software, we are installing guest operating system. Okay, on top of guest operating system, we are deploying applications. But whereas in case of container technology, okay, container technology, so we don't need to install operating system. Okay, we don't need to install additional operating system. If you see this image here, the guest operating system is not required. Okay, operating system is not required because this container will use the resources from this operating system only. Okay, this container will use the resources from this operating system only. It will use, the underlying resources like CPU, RAM, memory, and it will use the operating system. Okay, operating system. This is called nothing but a host operating system, and you can also install, one operating system on this container. Okay, it is not a huge operating system. You can simply get the image. Okay, operating system work కావాలంటే ఒక simple image ఉంది. For each and every operating system, there will be one image. Okay, for Docker, so let's say for example for Ubuntu, we have Ubuntu image, and for CentOS we have CentOS image. Okay, for Windows also we have one Windows image. So those images are very lightweight. Okay, they are like not like this regular operating systems. Those images are like very lightweight operating systems. Okay, so by default, when you install this container engine is nothing but which is required for creating containers. If you install this container engine, you can create containers. Okay, I'll explain that later. So in case of container engine, you don't need additional operating system. You don't need to purchase any licenses for operating system. Okay, but what it will happen is when you install that engine, okay, it will use the underlying operating system and this infrastructure. In case of virtual machines, you can install operating system, or you cannot. It is not required. Also, it is not necessary to be installed in a physical machine. You can install hypervisor software. మీరు hypervisor ఇన్స్టాల్ చేసుకొని దానిపైన గెస్ట్ ఆపరేటింగ్ సిస్టమ్ ఇన్స్టాల్ చేసుకోవచ్చు. ఓకే, మీకు ఏ అప్లికేషన్ కాదు రిక్వైర్మెంట్. బట్ ఇన్ కేస్ ఆఫ్ containers, you need one operating system, either it could be Windows or Linux, anything. Okay, on top of that, okay, on top of that machine, you need to install one container engine. Okay, one container engine, and on top of that, what I say, you don't need to install any operating system. By default, you can create containers. Okay, you can create containers and you can deploy your applications. అది ఎలాగో మనం చూద్దాం. ఫస్ట్ వచ్చేసి for containers, let's say for example, so the definition of container is nothing but it is an isolated workspace or user space for deploying the applications. Isolated అంటే separated meaning. Okay, it is an isolated workspace or user space for deploying applications. Containers use shared resources or underlying resource of physical machine. Okay, like operating system. Okay, operating system and the hardware resources like CPU, memory, and CPU, memory, and what is this? Process. Okay, CPU, memory, hard disk. Okay, so like this, container, it will use the underlying operating system and underlying infrastructure, and on top of that, you can create containers. But whereas in case of hypervisor, okay, in case of hypervisor, even hypervisor uses underlying operating system, underlying resources. But on top of that, you need additional operating system, okay, for deploying their applications. So here, the famous technology for containers is Docker. Okay, famous technology for this container is technology is called Docker. So the definition is Docker is an open source platform. Okay, or you can say platform as a service, PaaS, PaaS, platform as a service. So Docker is an open source platform for shipping, deploying, shipping, and running shipping, deploying,
హలో హలో
బ్రో వాయిస్ రావట్లేదు అన్న.
hello, sorry.
సాయి కిరణ్ బ్రో, మీ వాయిస్ రాలేదు.
ఎక్కడి నుంచి ఇప్పుడు ఇది కనిపించిందా మీకు?
నోట్ ప్యాడ్
Docker
నుంచి
is an open source.
Docker డిప్లాయింగ్ నుంచి కనపడాలి అంతే.
Okay. So Docker is nothing but open source platform for shipping and deploying your applications.
ఓకే. హలో హలో
వాయిస్ కట్ అయింది కదా మళ్ళీ.
మళ్ళీ కట్ అయింది.
యా యా
డేటా
Okay,
పోయింది అన్నది.
వినిపిస్తుందా అండి?
ఇప్పుడు వినిపిస్తుంది.
నాకు నోటిఫికేషన్ వస్తుంది, డోంట్ వరీ. సీ వెనెవర్ ఆడియో ఇస్ ఆన్ మ్యూట్ ఆర్ డిస్కనెక్టెడ్ ఐ గెట్ నోటిఫికేషన్. నేనేం ఎక్స్ప్లెయిన్ చేయను, అప్పుడు వెయిట్ చేస్తాను. ఓకే, సో
ఓకే.
check this. Okay, check this. So Docker is an open source platform for developing, shipping and running your applications. Okay, this is the base definition. Docker enables you to separate your applications from your infrastructure so that you can deliver software quickly. With Docker, you can manage your infrastructure in same way you manage your applications on physical server. Okay, so what is Docker's methodology? By taking the advantage of Docker methodology for shipping, testing and deploying your application code quickly. So the meaning ఏంటంటే డాకర్ టెక్నాలజీ ఏం చేస్తుందంటే మనకి కంటైనర్స్ ప్రొవైడ్ చేస్తుంది. ఓకే, కంటైనర్స్ ఎలా ఉంటాయంటే ఇక్కడ మీరు చూస్తే
ఇంట్రొడక్షన్ క్లాస్ లో చెప్పారు కదా బ్రో కంటైనర్స్ గురించి.
yes exactly. So if you say this, okay, if you say this, these are all containers, right? Let's say for example, if you want to transfer any goods in one container, you can transfer what do you say, clothes. In one container you can transfer your ornaments. In one container you can transfer your what do you say, fish. If you want to transport fish to some other location, you can transport like that. So like this, if you see this Docker image, Docker website, so this is a ship. On top of that, these blocks are nothing but containers. So the advantage of using this Docker technology is nothing but you can develop, ship and run applications on top of containers. Okay, we'll take this definition. Okay, so Docker is one famous technology for containerized what is it, applications. So let's discuss the difference between virtualization and what is this virtualization versus containers. Okay, this is one of the interview question. Okay, so virtualizers and containers. In case of virtualizers, okay, in case of virtualizers, in case of VMs, let's say we'll write like this, virtual machines. So in case of VMs, we need guest operating system. Okay, guest operating system. So in case of containers, okay, in case of containers, we don't need no need of guest OS. Okay, guest operating system, and instead we can use images. Images are nothing but Docker images. Okay, Docker images. So here, let's say for example, if you want to run 2 GB application, okay, it requires at least 4 GB RAM. Okay, for running 2 GB application, it requires 4 GB RAM. But in case of containers, okay, I am giving it as example. It requires my meaning, intention is it requires more memory. And more resources. Resources in the sense the hard disk and the CPU. It requires more memory. But it will be in GBs, okay? Virtual machines, it will be in GBs. Something like GBs, not MBs. It will be like GBs. If you want to deploy 2 GB application, you need 4 GB RAM, something like that. Okay? But deploying 2 GB application, you need 4 GB RAM. So like this, one virtual machine uses the underlying operating system. But whereas in case of these containers, Docker images are lightweight, okay? Docker images are in MB, okay? And Docker containers are lightweight. Okay, containers are lightweight. So lightweight in the sense they will be literally, in MBs. Images are also MBs. Image is nothing but underlying. What is it? Instead of operating system, we use the image, right? So our image చాలా తక్కువ ఉంటుంది, MB ఉంటుంది, 200 MB, 400 MB or 100 MB, like this. It will be in MBs. Okay. And third difference is it requires more time to reboot. Okay, more time to reboot. Miru, suppose if there is any issue, if you want to reboot the server or virtual machine, it will take more time. It will take minutes. Okay, let's say for example minutes. But whereas containers can be restarted. Okay, so audio only disconnect connect background noise. Hello, hello.
బ్రో
బ్రో
ఆడియో డిస్కనెక్ట్ అయ్యి మళ్ళీ కనెక్ట్ అవుతుంది హరి.
అవును.
ఎక్కడి నుంచి వినిపించింది నీకు లాస్ట్ ఆడియో?
యా ఇక్కడ నుంచే బ్రో.
రీస్టార్టెడ్ విత్ ఇన్ సెకండ్స్, అది వినపడలా.
Okay, so if you want to reboot your any virtual machine, okay, it will take more time to reboot. Okay, it will take minutes. Let's say for example 2 minutes or 5 minutes it will take. Okay, at least the minimum time required is 2 minutes. Okay, for example, if you want to restart any container, you can learn, you can do it in seconds. Within seconds you can restart your containers. Okay, this is the advantage of using containers. This is the major difference between what is it, virtual machines and containers. Okay, మీకు ఇక్కడ చూసుకుంటే ఇక్కడ మీరు చూస్తే container, in case of container system, okay, in case of containers, we don't have any operating system, right? So it is using the base operating system only. So it will act as what is it, an isolated user space or an isolated environment. If you restart it, it will take seconds only. But whereas in case of this, you have operating system, so it will take minutes. So that is the reason it takes more time to reboot. Okay. And the next thing is, okay, we discussed, right, containers and what are Docker containers. So the definition is same. Okay, Docker container is nothing but it is an isolated workspace or user space for deploying your applications. Okay, which is, it will be it is nothing but it is I don't know what is the problem. The audio is disconnecting and reconnecting each and every time. Okay, and also Docker architecture. Okay, so
సాయి మళ్ళీ వాయిస్ కట్ అయినట్టుంది.
now, hello, వినిపిస్తుందా శ్రీకాంత్ or Hari?
యా బ్రో
వినిపిస్తుంది
వినిపిస్తుంది.
బ్రో.
ఇప్పుడే వినిపిస్తుంది.
నేనేం మాట్లాడలేదు ఇంతసేపు. ఓకే, జస్ట్ డయాగ్రామ్ గీసా. ఓకే, so generally in case of Git, okay, let's say for example I am taking Git as example. Okay, Git లో Git terminal లో మనం ఏం చేస్తాం, ఇక్కడ let's say for example operations ఏం చేస్తాం, git clone URL. ఓకే, git clone URL, రైట్. అది చేస్తే ఏం చేస్తాం, గిటబ్ నుంచి, ఓకే, గిటబ్ నుంచి లోకల్ సర్వర్ లోకి కోడ్ వస్తుంది, రైట్.
ఫోల్డర్స్ రిట్రీవ్
గిటబ్
చేసుకుంటాం.
గిట్ క్లోన్ URL కొడితే రిమోట్ సర్వర్ నుంచి లోకల్ సర్వర్ కి సో కోడ్ డౌన్లోడ్ అవుతుంది. సో వాట్ ఈస్ ద యూజ్ ఆఫ్ దిస్ టెర్మినల్? On terminal, if you use git clone url command, okay, terminal, if you use git clone url command, what is it doing? It is cloning the code from repository, remote repository which is present in the cloud, okay, and it is importing the code onto your physical machine, your server, right? So like this we have Docker architecture, okay. Okay, I'm really fed up with this audio issue. I don't know why. So now my audio is visible, right? Audible, right?
Yeah, bro.
నాట్ నో బ్రో, ఇప్పుడు వినిపిస్తలేదు.
Okay, Sushmita, Hari, సో
సాయి
కంటిన్యూస్ ఆడియో ఇష్యూ వస్తుంది. ఒక పని చేద్దాం, ఈరోజు వర్చువలైజేషన్ ఇవన్నీ చూసుకున్నాం కదా, రేపు కంటైనర్ ఆర్కిటెక్చర్, డాకర్ ఆర్కిటెక్చర్, డాకర్ ఇన్స్టలేషన్ అండ్ రిమైనింగ్ యాక్టివిటీస్ చూద్దాం. ఓకే
ఓకే బ్రో.
ఇంకోటి
Bro.
హరి, హరి
నిన్న డౌట్,
చెప్పు హరి.
అదే నిన్న డౌట్ బ్రో.
మళ్ళీ ఆడియో డిస్కనెక్ట్ అయినట్టుంది.
అవును.
హలో, సో ఆడియో కంటిన్యూస్ గా డిస్కనెక్ట్ అయ్యి కనెక్ట్ అవుతుంది. ఒక పని చేద్దాం హరి, నేను నీతో ఎన్ని డేస్ లో కనెక్ట్ అయ్యి ఆ డౌట్ ఎక్స్ప్లెయిన్ చేస్తాను.
అంటే సుష్మిత కూడా సేమ్ డౌట్ ఉందంట, అందుకోసం.
యా పర్లేదు సాయి, తనకి చెప్పండి, తన దగ్గర తీసుకుంటాను. ఇట్స్ ఓకే, ఏం కాదు. క్లియర్ అయిన తర్వాత నాకు చెప్పండి హరి. సేమ్ ఎర్రర్ నాకు కూడా వచ్చింది, సో అది
ఓకే ఓకే ఓకే, అర్థమైంది. సో నేను ఎక్స్ప్లెయిన్ చేస్తాను మీకు. ఓకే, నేను ఎక్స్ప్లెయిన్ చేస్తాను ఎలా చేయాలి.
డన్ ఓకే, నో ప్రాబ్లం. ఓకే, దాని సెషన్ ఎండ్ చేసేస్తున్నా సాయి నేను. హరి, శ్రీకాంత్ సెషన్ ఎండ్ చేస్తున్నాను ఇంకా.
ఓకే ఓకే
ఓకే
థ్యాంక్ యూ.
థ్యాంక్ యూ.